ICoN, Immersive Computational Notebook for Data Science. Computational notebook tools have become essential in data science. However, users are growing concerned about limited interaction in specific tasks such as data transformation and data visualizations. Immersive data visualizations were proposed to allow dynamic interactions in data analysis for VR and AR environments. And also, immersive data transformation appeared to allow direct manipulation of data. However, alternating between these immersive analytic tools and computational notebooks seems inevitable. Growing interest in immersive analytics, immersive computational notebook has emerged. However, alternating between different immersive analytic tools still remain as a challenge, as these tools are offered as a standalone solutions rather than in a unified system. Therefore, we introduce ICoN, which enables the use of immersive data science tools and computational notebooks in a unified environment in a fully immersive manner. While our system aims for analysis to work in a unified environment, an efficient method for transitioning between various tasks is essential. In ICoN, they can transit between multiple tasks using embodied interactions such as pull-out and put-in interaction, and they can also interactively explore the data. Here, we have an example of using ICoN. We have cells displayed across multiple windows that are in a semicircular layout. We can select cells and can be run by clicking the execute button on the left hand. Then all the cells that are in a lower hierarchy will be executed automatically. We have 3D visualizations, 2D visualizations, and data cell. We have outliers in 2D visualization, but it's hard to find, so let's make it bigger. To remove the outliers, let's say we need to remove it from data table. To do so, we need to pull out the data table from the notebook. With this data table, we can also make it bigger, and we can also explore the data table, and even more, we can perform data transformation without writing codes. However, identifying such outliers relying solely on data table can be challenging, so let's try to make visualizations of data table. To do this, we can grab two columns, one by each hand, and merge it. The columns will convert it into axes and resulted in creating the visualizations. We can convert this into 3D visualizations as well. Now, it's easy to find such outliers. We can also interactively explore the visualizations. Since we delete the outliers, let's update the data table by just grabbing it and release it into the data table. Since the data table is updated, we can update data table back into notebook. We can grab it and release it into the notebook. Now, we will be able to see the outliers is removed from the notebook. And here, we also have 3D visualizations. However, it's hard to interact within the notebook settings. We can extract those flat visualizations into embodied workspace by just grabbing it and pull it out. Then we can intuitively interact with 3D visualizations. And furthermore, we can effectively compare the visualizations. And we can convert dimension for better comparison. Grab another dimension and put it into existing visualizations. We can make both graph into 2D dimension as well. And we can have another interaction with visualization, such as deleting, and another converting dimensions. Once we are done with exploration, we can update those visualizations into notebook for the purpose of sharing with others. With these features, we have conducted a usability study and we found the following valuable insights. We found unified setup accelerates the time performance than the separated setups. Also, participants in unified setup had a low efforts on their transitions. In terms of computing environment, while we found several trade-offs within their subsettings, we found the unified setup were better in VR, which also indicates that ICoN was effective. In summary, we believe ICoN enables a seamless transition in dynamically interacting with data. For more details, please have a look at our paper.